Okay, right. Um, okay. I explain another time. Now this thing here comes from another curve. This thing here comes from another curve. Okay. So this thing here comes from the first curve. The first curve, they are interested in the tangent. So I find dy dx. The second curve, they are talking about the normal. So after finding the tangent, I find the gradient of normal. Okay, now, so there are two curves. One, the blue color, equation in blue color. Another curve, the equation in green color. Two curves. How to match them? I match the green color normal with the blue color tangent. That is what they're talking about. Because the two of them, they are parallel. So the green color, I take the normal. The blue color, I take the tangent. Then I match them. Using the necessary values, the given values, I match the two of them. So how to match them? Matching them is from here. Matching them is from here, right? I match the two curves together, right? So the value of the tangent comes from the second curve. The point comes from the first curve, So I take these two values, I substitute into the equation of the function, the gradient function, to put inside. So I form another equation, third equation, this equation. By matching the tangent, the normal with the tangent, I arrive at another equation. Now this equation, I can solve together with this equation, the first equation. So solving these two equations simultaneously, I can find the value of h and k. Okay, may sound a bit confusing, but not really lah. Your mind must be very analytical, right? Analytical. Try to think. Okay, any question from this part B?
Teacher, M1 is the gradient of straight line.
M1 is the gradient of tangent to the second curve.
Then M2?
M2 is the gradient of normal to the second curve. Gradient of normal to the second curve.
Okay.
Okay. Then this normal to the second curve is parallel to the tangent to the first curve. That's why I can take the gradient and put inside. The gradient here, I can take the gradient here and put inside here, because they tell me it is parallel. That's why I put inside. Then together with the value of this point here from the first curve, put inside, then I get one equation. So this equation I solve with the first equation, I get the h and k. Never mind. If it's a bit confusing, then never mind. Normally they don't make it so confusing, right? Okay. Now the homework for today is this one, 2.9. Then the previous one is, where's the previous one? Oh, no more. Alamak. Where's the previous one? I deleted already. The 2 point, this one. Wait, never mind. I will copy and paste again. Okay, 2.9. This is 2.9. The previous one is 2.8. 2.8 and 2.7, I think. Okay. Here. Okay. So today's homework is this one, 2.8, 2.9, one more 2.7, I think. 2.7. Yes, 2.7. Okay, so 2.7, 2.8, and 2.9. Okay, so these are the homework lah, homework for the previous lesson, right? So the next topic is about turning points. You have learned about turning points in school. If you don't understand, never mind. You pay attention now and you listen. I'm sure you know what is what are turning points at the end of this lesson, right? You will know what is turning point. Okay, sabar, see how many people are here. The same few girls here. Okay, right. Turning points. Now I have drawn four curves. Okay, four curves here. 1, 2, 3, 4. I've drawn four curves. On these four curves, I have marked each of these curve. I have marked 1 point. Okay, so the first curve I mark 1 point. I call it A. Second curve I mark another point. I call it B. Third curve I mark another point. I call it C. And the fourth curve I mark another point. I call it D. Now these points A, B, C, D, these points, I do some tricks first. Okay, 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 right. So on each of these curve I've drawn 1 point, and curve number 1 I draw point A, curve number 2 I draw point B, and so on, right? Now these 4 points A, B, C, and D, they are turning points. Now then you ask, eh, these are turning points, okay. uh why are they called turning points? Why are they called turning points? Okay, so I am going to explain to you why they are called turning points. Now before I tell you why they are turning points, they are points on the curve where the gradient of tangent starts to change, right? So when they start to change from one value to another, that is the turning point. I just show you the segment. Now at this point A here, the dy dx is 0. At this point B here, the dy dx is also 0. At this point C here, the dy dx is also 0. At this point D here, the dy dx is equals to 0. So turning points, they are points on the curve where the dy dx equals to 0. Okay, then these turning points, they are also known as stationary points. Okay, stationary points. Okay, right. So these stationary points, There are three types of stationary point. Now you see this curve, they go down, then they start to turn up again. So this turning point here is called the minimum point. Now this curve, the green color curve, it goes up, then turn down again. So when they turn down again, at this point here, where they start to turn, at this point B here, they are called turning points. And the gradient here is 0, right? Now look at the third curve, this blue color curve. You see it go up, then at this point they start to turn to become 0, then they turn up again. So this point C is the turning point. At this point the dy dx is 0. Okay, we look at the last curve. We come from here, green color, go down, 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 then they turn and become flatten, then they turn down again. So it is at this point D that the gradients start to change. So they are called turning points. And the characteristic of this turning point is the dy dx is 0. The gradient at these points, they're 0. Okay, so why they are called turning points? Because they start to turn, right? They start to turn at this point. You see, all the time they go down, 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 then they turn up again. This one, up, 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 then they turn down again. So they are called turning points. Here also, turn, then go, turn the other way around. It's supposed to go this way one, then they turn the other way, turn up again. This one go down, right? Supposed to go up, but they turn down again. So these are called turning points. So this type of turning points here is called a minimum point. This turning point here, because it's the highest point, it is called the maximum point. And this point here, because it's neither maximum or minimum, so it's called the point of inflection, F-L-E-C-T-I-O-N. But some books they spell as inflexion. So both pronounced as inflection, but different spelling. Both also they use, but normally in our textbook, our FLECTION, right? The XION one maybe American spelling or what, right? This one is also called the point of inflection. So turning points, three types: minimum, maximum, and point of inflection. The three types of turning point. Characteristics of this turning point, and you know they are turning, but what is the characteristic? Mathematically, dy dx is 0 at these points. Any question? Other girls? Other girls? Ah, mm, other girls don't know can follow or not? Ang Yifen said can repeat or not. Okay, repeat, repeat. Okay, right. Now the points that I've shown you here, A, B, C, D, they are called turning points. Okay, so we want to know why they are called turning points, right? We want to know why they are called turning points. So we look at curve, the curve A, right? So this thing will go down, 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 down. Then they go up again. So at this point A, they start to turn up again. So it's called turning point. This one B, they go up, 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 then they come down again. So they turn, then they come down again. So this point B is called turning point. C, they come until flat. Okay, flatten already. At the point C, they flatten already. Then if you continue some more, they turn up again. So this at this point, the gradient actually start to change. From this way, then they swing another way. From this way, they swing another way. So this point C is called the turning point. Then from here, right, we come down, 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 down. Then the curve flatten already. flatten. They come down, then they flatten. Then they start to turn down again. So this point D, they start to turn. So this is called the turning point. Now this is what we can see with our eyes. Mathematically, what is this point? Okay, what is the characteristic of this point mathematically, which we can count on, we can calculate. We don't want something that see with our eyes, just like physics like that. Wow, all the things you must quantify, all must have numbers, must have units, must be able to count. So mathematically you just see, oh, turn here, turn there, turn. Not enough. Mathematics, we must know how to count. So in order to count, this point A here, the dy dx is 0. At the point B here, dy dx 0. At the point C here, dy dx 0. At the point D here, dy dx is 0. Turning point is what we can see. Dy dx is what mathematics can see. Mathematics can see that, oh, the gradient there is 0. Any more question? Ethan? Got any more question or not, Ethan? Okay, no more question then. We go on to, you remember this lah, dy dx equal to 0. Turning point dy dx 0. They can be maximum, minimum, or point of inflection. So there are 3 types. Okay, right, next. This one more, this one more complicated. Now you don't read the words yet. These words you don't read yet. These words you don't read yet. These words you don't read yet. Wait. Okay. I cannot. I must hide one by one. Hide one by one. One. Okay. I put this thing over here. Okay, this one I hide. Okay, this one I hide. Hide, that means not to confuse you lor. If I show everything then you tak boleh faham lor. Okay, so I hide everything first. Tang 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 tang. Okay, hide everything. Okay. Turning points. Turning points. When we say dy dx equals to 0, right? When we say dy dx 0 here, right? All these points dy dx 0, we can actually use the dy dx equals to 0 to calculate the coordinates of these points A, B, C, and D. Okay or not? When we use dy dx equals to 0, we can actually calculate the coordinate of this point A, point B, point C, and point D. However, we do not know what type of turning point it is. Let's say if the curve is not shown to you, and you can only find the turning point using dy dx. Wow, put dy dx equal to 0, find the turning point. Then people ask you, hey, what type of turning point is this? Maximum or minimum? Then you cannot tell. So there are 2 methods of determining the type of turning point, whether it is a maximum or minimum. We are more interested in maximum or minimum. This point of inflection, not interested. Tidak berminat, right? We want to know whether they are maximum or minimum. So there are 2 methods of finding out whether they are maximum or minimum point. The first method is called analysis of gradient. We try to analyze the gradient and see, right? Then the second method is using the second derivative. We find the d2y dx square. From the d2y dx square, they can tell us whether the point is maximum or minimum. Okay, so far any question before I continue? Now, what we have seen is turning point. Okay, turning point. How to find the turning point? Put dy dx equals 0. How do you know what type of turning point it is? Right? So we are going to use this method, analyze the gradient. We analyze the gradient and see what type of turning point it is. So far, any question before I proceed? Jia Yan, any question? Jia Yan? No, then I'm going to tell you how to see why it is maximum, why it is minimum. Ah, okay. Jia Yan said okay, oh, no problem. So now I'm going to tell you. Now, whatever we do, we move from left to right. Why we move from left to right? Now you remember the x-axis, left side is the smaller value of x. As you move to the right, the value of x become bigger and bigger, right? So as x increases, we are going to see what happened when x increases. What is going to happen? Okay, right. Now we look at this curve A first, the curve with point A first. Now I have another point on the curve, I call it A1. A1 is on the left hand side of A, which means that the value of x is smaller than A, smaller than the value of x of the point A. Then I move this point A nearer and nearer to this A1, nearer and nearer to A. This is the tangent. This is the tangent. Now the coordinate of A1 is negative 0.9 and 0.4, right? And the gradient of tangent at this point A1 is negative 0.9. Remember, negative 0.9. So when I move it nearer and nearer to A, what happened to the value of the gradient? It becomes negative 0.6. Then I move until A, it becomes 0. After they pass A, what happened? What happened to the gradient? The gradient becomes positive 0.9. Then I move the tangent further away. It becomes positive 1.36. So one more time, you tell me how the gradient change before A and after A. How the gradient change? Can you tell me? This is before A. What is the gradient? You see, what is the gradient? You see that red color. After A, what is the gradient? Can you tell me what you have seen there?
Mm.
Can you tell me?
Be
Ah,
before A, the gradient is negative. After A is positive.
correct. So that means for this minimum point A, for this minimum point A, before it is negative, after it become positive. So from the analysis of gradient, by looking at the value of the gradient, I can know what type of turning point it is. I am very sure now, if it moves from negative to positive, then this A must be a minimum point. So we show how to show. Nothing to show. What did I show? Oh, this one. Oh, this one. What happened to this one? What happened to this now one? Aduh, deleted off already. I don't know how many times I can reverse. Never mind. Never mind. I copy here. Then I say copy. Then I say paste. Paste. So I take this. I move over to this side. Right. Okay. Now I'm going to type what Li Ying told me. As the point A1 moves from left to right means left of A, right of A. From the left hand side of A, they move to the right hand side of A. So as the point A1 moves from the left to right of the turning point A, the gradient changes from negative to positive, negative to positive. The point A, the point A is a minimum point, minimum point, minimum, minimum point. Okay, save, save, file, save. Okay, uh, can understand what I have written here? Can or cannot?
Can, teacher.
Can. Okay. Now we go on to this curve B. Curve B, the turning point is B here. This point here. The turning point is B here. So I take a point B1 on the left. We always start from the left because left is small. Small to big. Small to big. Big X. The X is small to X is big. Now can you tell me what is the gradient of tangent at this point B1? 1.38.
Po-
Hmm?
Positive.
Positive, correct. So I move lah. It become less and less positive. Become smaller and smaller, less positive, then become 0. 0 then become what? 0 then become negative.
Negative.
Negative. So the gradient before B is positive. The gradient after B is negative. So what type of turning point is this? This is maximum point. So we say that as the point B1 moves from left to right, left to right means from a smaller value of x to a bigger value of x. From a smaller value of x to a bigger value of x, what happened? Okay, as the point B1 moves from the left to the right of the turning point B, the gradient changes from from positive to negative. So if from positive to negative, the point B is a maximum point. So far, the maximum and minimum is the most important. The other two type not important, right? They are not going to ask in the exam. So now these two type, any question or not? Do you know how to find turning points? Yes, dy dx equals to 0. Do you know how to determine whether they are maximum or minimum point? Yes, either they are positive to negative or negative to positive. Any questions? Soalan, soalan.
No, teacher.
No, no, no. Then we continue with this point C. Oh, now they come back. After I type mati, I type, then they come back. Okay, never mind. I delete off one. Mati, I go and type. Then delete one. Delete one. Okay. Then delete off all this. Okay, right. So at this C here, I move from left of C to the right of C. What can you tell me? On the left hand side of C, what can you say about the
Both
gradient?
both positive.
Positive, then becomes less and less positive, less and less positive, then becomes 0. 0 then also positive, but more and more positive. So this type of point where you change from positive to positive, right? Positive to positive, then is the point of inflection. Now we look at this d. Oh, now my d disappear already. Never mind. So this d, from the left hand side of d, I move to the right hand side of d. What happened to the gradient here? You look at the gradient here. The gradient here is negative. So I move, it becomes 0. Then 0, I move further to the right, it becomes negative. So from negative to 0, back to negative again. So this is the point of inflection. This is the point of inflection. Okay. Now let me make all this come out again. Okay, didn't come out already. So everybody come out, I delete this thing. Okay, right. So we have this analysis of gradient. Now, how to make use of this, I'm going to show you in the next lesson, right? Now we go on to another one. Turning points, right? Or stationary points. Determine the type of turning point using second derivative, that is d2y dx squared. Okay, right. We look at this. Just now we already seen this, right? Now, we look at it in terms of dy dx, right? The dy dx changes from negative to positive. Okay. The dy dx changes from negative to positive. Dy dx changes from negative to positive. Okay. Now, I ask you, the value of dy dx increases or decreases as it changes from negative to positive. From negative to positive, dy dx increase or decrease?
Increase.
Increase. Now, when you say increase, that means you read this line, dy dx increases as x increases. The rate of change of dy dx with respect to x is positive. Now, when you say increase, that means the rate is positive, right? Increase means positive. So rate of change of dy dx with respect to x, this thing, rate of change of x with respect to x, it is actually your d2y dx squared. The rate of change of dy dx is d2y dx squared. So if you say increase, that means you are saying that it's positive. You say it's positive, that means you are saying that d2y dx squared is also positive. Now, if you look at the maximum point, right? The dy dx changes from negative, from positive to negative. Okay, positive to negative. Can you tell me the dy dx is actually increasing or decreasing? From positive you go to negative, so the dy
Decrease.
dx is decreasing, correct? So we continue to read here. Dy dx changes from positive to negative. That means the dy dx decreases as x increases. Now this becomes something like your physics already. Who is teaching physics the other day, you told me? Not Puan Tan, right? The other teacher.
One Shadila.
Shadila. So this sounds something like your physics one. dy dx changes from positive to negative. It means what? Dy dx decreases as x increases. Okay, it means that the rate of change of dy dx with respect to x is negative. Decrease, dy dx decrease means negative, right? But the rate of change of dy dx is actually d2y dx square. So means the d2y dx square is negative. Okay, never mind. Slowly, slowly. So Ang Yifen gone for tuition already. So now I ask Zini. Zini can understand or not? Oh, can. Jeannie said can understand. Very good. So, so how many ways of determining the time of turning point? Two ways. One, using the analysis of gradient, and the next one using the second derivative. Okay, right. So, in the next lesson, I'm going to show you how to, oh, this one terbalik, how to use the analysis of gradient to find out the type of turning point, right? First of all, we find the turning point first. Then after that, I'm going to show you how to decide what type of turning point. Let me show, right? I am also going to show you, right? I'm going to show you how to use the second derivative. So we use the first derivative to find the turning points, right? Find the turning points. After that, we are going to use the second derivative to show what type of turning point is it. If it's a positive value, what type? If it's a negative value, what type? Right? So this one I'm going to show you the next lesson. Now only 2 minutes left. Cannot show already. I can just explain to you the meaning only. So you remember to do the homework. That's all. This homework 2.7, 2.8, and 2.9. So tomorrow I'm going to explain to you how to find the type turning point. But anyway, if you have questions tonight, you can ask me through the Telegram. I show you, or if I cannot show, I will show you tomorrow the first session. First session, I show you how to do all this. Okay. That's all for today, right? Thank you.
Thank you, teacher.
Thank you.